A universe out of nothing? How is that possible? If there is a one-time beginning to this huge star-studded universe, where did the initial bundle of energy come from? Or did the whole thing come out of nothing? Let us ponder over this question today.
Are you curious about the world around you? Do you wonder what else is out there beyond our world? Dr. Latha Christie, a scientist and an author, will take you on a journey through the universe. Join her in exploring the universe through her web series, The Grand Cosmic Story. Stay tuned to find out what today's episode is all about.
First, let us find out what's the universe made of. What is matter composed of? And what holds it together? What's the world made of? Both the mega things that we see around us, things like mountains and stars, and the micro things that we cannot see, like the terrible coronavirus. Scientists have long wanted to find the most basic building blocks of the universe. Democritus, an ancient Greek philosopher who lived around 2500 years back, was the first person who theorized that everything in the world was made of atoms. Then John Dalton proposed the atomic theory, which states that all matter is made of atoms that are indivisible. Do you know that about 99% of your body is made up of atoms of hydrogen, carbon, nitrogen, and oxygen? Towards the end of 19th century, J.J. Thomson stunned everyone by telling that he discovered a negatively charged particle that was smaller than the atom called the electron. Then in 1911, Ernest Rutherford found that an atom is made of mostly empty space with nearly all its mass concentrated in a tiny central nucleus consisting of protons with positive charge and neutrons with no charge, surrounded by negatively charged electrons. What keeps protons from repelling each other within the nucleus? Why are they not flying apart? The key to understanding this is to know the fundamental forces of nature. There are 4 of them. The first force is gravity. The second force, which is the most interesting force, is the electromagnetic force, which is a combination of all magnetic and electrical forces. This is the force that enables your fridge magnets to stick to the fridge. The other 2 forces are the strong nuclear force and the weak nuclear force, which operate only within the nucleus of the atom. The strong nuclear force, the strongest of all the 4 forces, acts between protons and neutrons and glues them together inside the nucleus. Atoms that were once thought to be indivisible were found to be made of electrons, protons, and neutrons. Particle physicists wanted to know whether they can still split these ingredients of atoms. So they decided to play games like the kids who crash cars one against the another on their screen. They use gigantic machines called particle accelerators or atom smashers to smash atoms into pieces so they can learn what is inside protons and neutrons. They found that electrons are indivisible, but neutrons and protons can be still divided, and they are made of subatomic particles called up quark and down quark, which are combined in various ways. The branch of physics that deals with the behavior of matter on the scale of subatomic particles is called quantum mechanics. Before the discovery of quantum mechanics, the prevailing belief was deterministic. The idea that everything in nature was caused by reason and necessity rather than random occurrences. However, the quantum theory suggests that nature can be probabilistic too. While the macro universe is highly ordered and follows certainty, the quantum world or the micro world includes probability. The quantum world is strange and downright bizarre. When we think of light, we think it is like a wave. But in the year 1905, Einstein proposed that light came in chunks or light quanta called the photons. We cannot see the photons, but rocks with better eyesight can see individual particles of light photons from the light bulb. However, scientists were perplexed when they carried out Thomas Young's double slit experiment using a photon. A single photon could go through both the slits at the same time or interfere with itself in a wave-like way and change its behavior when observed by a detector. This so-called wave-particle duality gave rise to a big question. Is light a particle or a wave or both? In classical mechanics, we know that a particle can be either here or there, and that's easy for us to grasp and verify. But a fundamental theory in quantum mechanics called the Heisenberg's uncertainty principle stated that a particle can both be here and there at the same time and exists only as a blur of probability until someone measures it or observes it. Quantum mechanics was so radical a theory that it completely shattered all previous waves of understanding reality. Einstein could not accept the strange idea that nature can present us with probabilistic 2 at a quantum scale. In 1927, all the world's leading physicists gathered at a conference in Brussels to debate this controversial issue. What does quantum mechanics have to say about reality? This conference was remarkable in that 17 out of 29 attendees became Nobel Prize winners, including Marie Curie, who won Nobel Prizes in 2 separate scientific disciplines. At that conference, Einstein expressed his displeasure with quantum mechanics and huffed, "God does not play dice." Danish physicist Niels Bohr, the pioneer of quantum theory, argued against Einstein. Quantum mechanics predicted that two particles can get entangled, stay connected, so that the actions performed on one of the particles affect the other, no matter the distance between the two particles. This was proved by John Bell's experiments that showed that when two particles undergo entanglement, whatever happens to one of the particles can instantly affect the other, even if one of the particles goes in a rocket. Quantum mechanics gave rise to quantum cosmology, and a few researchers proposed that random quantum fluctuations or the temporary tiny fluctuations in the amount of energy could have produced matter and energy out of nothingness, and that the whole universe could have come from nothing. Since quantum mechanics states that the vacuum state is not truly empty but consists of fleeting electromagnetic waves and virtual particles that pop into and out of the quantum field, the researchers thought that an external field like gravity could have triggered a runaway effect in these quantum fluctuations, which would have caused them to grow so large that they could have brought this whole universe into existence. However, this model has many serious problems. Firstly, to trigger the quantum fluctuations, an external field is necessary. But how did this external field come into existence? Secondly, it's highly improbable that random fluctuations alone can produce such an orderly, beautiful universe. Thirdly, if an entire universe can pop up from nothing, it's also possible that could be a mind-boggling set of universes springing into existence elsewhere even now. These theories are all good for science fiction movies, but these theories do not have hard evidence and are highly ambiguous. Let me give an illustration for the question. Can something come out of nothing? Construct a room and completely seal it with no dust and no light inside. Now, there is absolutely nothing inside that room. After a few years, you break open the seal to find a beautiful cake baked and kept inside. Remember that there was absolutely nothing inside the room to cause the cake to show up. Would you not wonder? How would anything just show up in that empty room? What could be the reason why this came to be? Will you consider it as something magical or supernatural? Or will you rationalize that maybe a tiny particle could have shown up somewhere inside the room which later became a cake due to the long time interval? Even if a tiny particle showed up from somewhere and given a very long time, it cannot become a cake on its own. This is because though things happen over time, time itself does not accomplish anything. In the same manner, before this huge universe came into existence, something else must have existed. This is because an absolute nothing would not be able to bring out this carefully designed universe into existence. That something should have the power and wisdom to bring this life-spawning universe into existence from nothing. And that something must be able to exist without depending on anything else. That something must be the efficient cause that could bring the universe into existence without any material cause. Could that something be whom we call God?
In the beginning was the Word, and the Word was with God, and the Word was God.
If there is a supernatural creator who created the whole universe, I am sure he can intervene too and cause what we term as miracles. At the quantum level, we observe many strange things. The macroscopic world and the microscopic world constantly intertwine, and they do not exist in two watertight compartments. Though we have made tremendous progress in understanding the universe, there are still strange realms of the cosmos which looks paradoxical. Such cosmic paradoxes cannot be resolved by scientific approaches alone, but can be unlocked only if you involve a supernatural element within. Bye. See you next time.